Okay, welcome. We are live on track 2 with Ben, and we're going to be talking about event-driven Python serverless microservices. So all those buzzwords right there. So Ben, if you're ready, I will give you your full 45 minutes.
Awesome. Thanks so much. And thanks everyone for joining. Yeah, a few buzzwords in the title, so we'll break that down. But yeah, we're going to be talking about event-driven Python using serverless and how we can approach a microservice split in that. We're going to talk about the best practices for building systems in a serverless way in Python and how event-driven can help. As mentioned, my name's Ben. I'm the VP of Engineering at Theodo. We help other companies launch digital products, be that startups launching their initial MVPs to large companies doing sort of digital transformation. I'm also an AWS serverless hero, which means I get to do talks like this and work with the community, running the serverless meetup in London. And I'm also the editor of the Serverless Transformation blog, podcast, and newsletter. So if you're interested in any of that content, feel free to take the links here. The slides will be public later. And if you follow me on Twitter, I talk a lot about this sort of stuff. As you probably gathered from the previous 2 slides, I talk a lot about serverless, but I think it's good that we break down what we mean. So serverless is the future of the cloud, a range of services that allow you to rapidly build and run applications without compromising on security or cost. That's sort of the business angle to how we talk about serverless at Theodo. But if we break it down a bit more technically, what is it? Well, for me, it's an architectural movement. It allows you to build and run applications and services without thinking about the details of the underlying server that is running it. Developers send their application code and it's run by the cloud provider, for instance, AWS, in ephemeral isolated containers. And it's also the leveraging of third-party services to manage things like backend logic and state, things like Firebase or Cognito for identity as a service, or outside of AWS, things like Okta or Auth0. A bit confusingly, there's a framework with the same name, the serverless framework, which although a very good infrastructure as code tool, won't be what we're talking about today. We're really talking about serverless, the architecture movement. Now, why do people build applications in a serverless way? Well, first of all, there's a cost reduction. Depending on the usage of the application, you can make a much more efficient cloud build, depending on if you're running servers constantly or if you're running in a serverless way and only paying per use. Also, there's less ops required. It's not quite no ops, but there's a lot less ops required in terms of the amount of time spent on infrastructure, although developers are exposed to a lot more operational concerns. Developers can focus more on delivering business value because they spend less time writing infrastructure. And the services that you build are scalable from day one. And a more interesting point is, as we start to make more efficient usage of the servers and data centers, we can actually start to build greener architectures that have a lower carbon footprint. Now, when people hear serverless, they may have had exposure to AWS Lambda, which is the function as a service from AWS, which allows code to be run in those isolated ephemeral containers. Basically send application code and have it run in response to an event like HTTP. But applications generally require more than just compute. They need storage and data and APIs. And this is where the other serverless services come in. Things like S3 to provide serverless storage, DynamoDB as a serverless database, API Gateway as a serverless API proxy, Cognito for identity as a service, serverless queuing systems like SQS, step functions for workflows, and EventBridge, which is a serverless event bus, which is something I'm going to talk about later, and how we can sort of orchestrate these serverless microservice architectures. So where does Python come into this? Well, there are a number of different runtimes for the functions as a service, the compute part. And Python is particularly my favorite because it has one of the lowest cold start times and best performance. Not only is it a great language to write in, as I'm sure we all agree, but it has very good performance. Now, when I talk about cold start, this is the time it takes for the container to get up and running when a request comes in. Now, those containers do stick around, so subsequent requests have a much lower latency. But that initial cold start time is something that's a particular issue for languages like Java. Python, on the other hand, has one of the best cold start times and some of the best performance when it comes to serverless. And there's a range of different versions of Python supported natively in AWS, but custom runtimes are also possible. So you can package your own version of Python and then run any particular version that you want, be that ahead of the curve or supporting some legacy. What does a Lambda function look like? Well, a Lambda function responds to an event. It's a piece of code that developers can write and then have that run in response to the event. And this revolves around something called a handler function. This is a function that takes an event in a context, does something with it, and then returns. Now, the events can be, the event body can be a dict, a list, a string, an int, a float. The typing isn't too strict there. And the context would be metadata around things like headers on that request. Not all handler functions respond to HTTP, but when they do, the response here will then, the return of this function will then be the response that comes back from that API request. These Lambda functions, the compute part of our architecture, can be triggered by a number of different services. As we start to use all those different services I talked about before and some other ones, we can start to have code running in response to cloud native events, events being generated by the underlying services that you might use. Things like Cognito, CloudFront, API Gateway, Kinesis. I mean, I could list a lot of AWS services, and the same applies in different cloud providers, though AWS does have a very good link between these events and then running the function as a service code. And all of this gives a lot of power and flexibility. We can use Lambda, we can use a number of different runtimes, Python being probably the best one to run in my opinion. And then we can use a number of different services to orchestrate with that, things like DynamoDB, API Gateway, EventBridge, step functions. But all of this gives us a lot of power and flexibility, but very few best practices and guidelines about how we should be building. I'm not sure if you're familiar with the term, but it's a term I quite like when we're talking about software systems, the big ball of mud. This is a software system that lacks perceivable architecture, often caused by things like business pressures, developer turnover, and code entropy, probably things we've all seen across our careers. But also a cause for big ball of mud architectures is a lack of best practices or a lack of conventions around how things should be done. These big ball of mud architectures evolve when there's a lack of best practices and conventions, as well as business pressures, developer turnover, and code entropy. And obviously what we want to get to is nice logically grouped services based off the underlying business processes with very few dependencies between them. And that's a nice world to get to. But sadly, a lot of serverless architectures can end up as a Lambda pinball. This is a term coined by someone at ThoughtWorks, but it's the idea of a request coming in and bouncing around a sort of pinball of different services. Maybe it starts as a Lambda, it goes into an SQS queue, triggers a step function, maybe goes through Kinesis and then hits another Lambda function, which is a DynamoDB stream. Basically, the request comes in, it bounces around a number of different services and comes out somewhere. Not only is this hard to reason about in terms of observability, it's very hard to change a system with so much interdependency and chaos. This is how we get to our big ball of mud in a serverless architecture. So how do we avoid this? Well, microservice architectures work best when there's a clear split into services, services being sort of a layer on top of the underlying business processes. These services should be able to be deployed independently and only communicate with each other asynchronously, as well as mastering their own databases, mastering their own data, by which I mean not sharing databases. And this is nothing new. For those of you who are around for the service-oriented architecture movement, which came before the microservice architecture movements, this had many of the same tenets. And interestingly, service-oriented architectures made extensive use of something called the enterprise service bus. This bus was a communication mechanism for different services to talk to each other. If we break down the term, enterprise implied its use in large enterprise organizations to tackle those complex domains. And historically, there was a lot of infrastructure investment needed to run an enterprise service bus. Service was because it was providing the communication mechanism between a number of different services, those logical, self-contained representations of business process. And finally, bus, as you would imagine, referring to the hardware component of computers that allows signals to go between different components, here the different services. So through this, different services could put events into the bus and be picked up by other services, which tackles a lot of the pain points that come with building distributed systems and building serverless architectures. But what signals are going across this bus? Well, throughout this talk, we're going to talk a lot about event-driven. When we're talking about events in the context of this talk, we're talking about business events, business domain events. So an event is a significant change in state, and we're going to be focusing on those significant changes in state from the business perspective. And this is where Amazon EventBridge comes in. So Amazon EventBridge is a serverless event bus that connects application data from your own applications, SaaS, and other AWS services. It's been viewed by the serverless community as one of the biggest announcements since Lambda, which was that function as a service compute element, and is a key component for building event-driven serverless architectures. A lot of the event-driven serverless architectures we build at Theodore often make extensive use of Amazon EventBridge to act as that enterprise service bus. So here we have different services putting events into the bus, and then they can trigger other services. Now, it's not exactly the same as the enterprise service bus. It's a much higher level of abstraction. It's also completely serverless with no management of that bus required and no infrastructure investment here. And it's also simple to integrate between different cloud native services, making it a lot easier for developers to get up and running with putting events into the bus, publishing the schemas of those events, the structure, and having those be known by other teams so they can coordinate without necessarily having their code tightly coupled. And this helps us avoid the Lambda pinball. As ThoughtWorks point out, it's typically hard to test these applications, as we talked about before, but one pattern we can use to avoid this is to draw a distinction between the public and published interfaces and apply domain boundaries with published interfaces between them. I really argue that the published interface should be events, and we're going to see how we build those domain boundaries in those events as we get later into this talk. This is exactly where we get to. So how do we start? So we know that we have these different powerful services. We know that we have this concept of an event bus, which could really help us. But how do we go from our complex business domain to the structuring of these different contexts and the event structures that go between them? Well, this is where domain-driven design, and in particular event storming, can be very useful. I'm sure a lot of you are familiar with domain-driven design, really useful when you have complex business domains. Event storming is an extension of domain-driven design that is a workshop that allows you to discover the domain events, the boundaries, and the entities, or aggregates as they're called in domain-driven design. For the purposes of this talk, we're not going to be too strict on domain-driven design terminology. We're mainly going to focus on events, boundaries, and entities, and we won't talk so much about aggregates. We're specifically going to do some EventBridge Storming. So EventBridge Storming is a specific variant of event storming that reduces the rework and tight coupling for teams building serverless event-driven architectures with EventBridge. This is going to guide us through how we can use EventBridge to avoid that big ball of mud architecture. And it's split up into about 8 steps. And we're going to gloss over some of them today, but we're going to go through from start to end how we can go from discovering the events in our system to building out an event-driven architecture with Amazon EventBridge. So the first step is event discovery. And this is a whiteboard exercise you typically do with representative from the business, from the tech side, and preferably getting people across different business silos to collaborate. Now, obviously these days we can't do this in person, but tools like Metro Retro are really useful to do this in a distributed sense. And I've done about 3 or 4 of them since lockdown, and they've all gone very well remotely. In fact, remotely can sometimes help people to have more confidence in putting forward their ideas on this sort of workshop. So the first stage of this is event discovery. This is where, as a group, we're going to put all the different business events, those significant changes in states, onto a whiteboard. The key thing here is to use verbs, the doing words, and do them in the past tense. Things like order place, order dispatch, help ticket opened, store opened. Payment success here should actually be payment succeeded, but maybe I'm just trying to catch you out. We're going to take about 40 to 45 minutes in a real workshop, and much longer for more complex business domains, to get people to put these events on the board. It's not about focusing on putting them in the right order. It's not about focusing on cleaning up duplicates. It's really giving everyone in the room the ability to put forward their idea of what the current events in the system look like. The next step after this is temporal sequencing, putting things in order. From left to right, putting things in time order. When things happen at the same time, stacking them vertically. This is also a good time to remove duplicates and also spot missing things as you go left to right across the different processes. Quite naturally out of this stage in the process, you'll start to see logical sub-processes in your business, which allows you to then later on see how they'll fit into the different boundaries of your services. After this comes categorization into entities. So first of all, we've got the events, we put them in time order, and now we're going to look for the different entities that exist in our system. And I'm going to not focus on the difference between entities and aggregates for the purposes of this talk. So we're just going to look for the nouns that are mentioned in the different events that we've elaborated. So things like order, payments, customer, seller, store, help ticket, item. By attaching these to the events, we can start to see where these different entities are used. And also we can capture how some teams might use the same term to mean different things. In large organizations, order for the sales team might mean a customer's placed an order for an item, whereas order for the returns team might mean someone wants to return an item. An order for the support team might mean someone's opened a support ticket. By catching the sort of logical inconsistencies in terminology across the business, we can make sure that we structure our systems to have clear boundaries in where those terms are used so that the code doesn't get very complicated. And also we can challenge the business to align on what the terminology is, because the more complex the business terminology is, the more complex the resulting code is going to be. And the communication overhead between the technical team and the business team will get more difficult. So we've now got our names. The next step is another step of categorization into something called bounded contexts, which is another domain-driven design term. So what is a bounded context? Well, it's a set of language consistency. It basically means that a term can be used ubiquitously to always mean the same thing inside of that context. So order always means a customer's placed an order inside a particular bounded context. It generally represents the business process of a single team with a few stakeholders. And our job is to try and eliminate the dependencies between these different bounded contexts. Now, this can seem quite conceptual, and domain-driven design does require a lot of reading and sort of practice to try and understand the concepts. But really here, try and focus on grouping together the different event flows that we saw before into what seem like logical groupings that don't have lots of dependencies between them. Now, it might be that we see entities appearing across different bounded contexts. And this is actually fine, but it probably means that we need to handle the entity differently. Maybe it means different things to the business, or maybe there's going to be some data duplication we need to do to make sure that we don't tightly couple services that shouldn't be tightly coupled. After we've gone through that grouping, so we've grouped those different events and those different entities into sort of logical bounded contexts, and we're not sharing too many dependencies between them. We might have the same entity in multiple bounded contexts, but we know we're doing it intentionally. It comes to building the microservices. So one of those bounded contexts may actually have multiple microservices corresponding to those underlying entities. And if an entity appears in multiple bounded contexts, as we talked about before, this implies that there should be two independent microservices to handle the different business processes of those different contexts. Now, this can mean that data duplication is needed, which sometimes is something we have to do, but obviously we need to think carefully about what's the transactional consistency of that. But by highlighting that at this point and making sure our design is good at this point, this prevents the complexity of dealing with either a huge distributed monolith later or lots of interdependency between our services. Now comes to actually the technical part of applying an event bridge. So Amazon EventBridge allows you to create multiple event buses. Now there are different types of event buses. There's a default event bus for all the default AWS events. There's an ability to integrate SaaS providers to have their events go into that event bus, things like a payment provider. But we're going to focus on the custom event buses for our own events. So we're going to define our own events, have them go through a custom event bus, and then have that apply the routing rules to know what services should be triggered. And we often find best successes made when you use a single event bus, because rather than having teams coordinate on which bus they need to connect to, instead they know there's a single sort of bus that then they can listen to and know that the events that they're expecting will go across that bus. Now there can be specific cases of high frequency or maybe sensitive data that needs to go across different buses, but in general, we're going to focus on one bus for the data going across. The events that go across this bus will have a structure, and this is where that published interfaces part that was talked about earlier comes into place. Teams should be able to work independently to deploy their services, but they need to agree on the structure of the events that go between the services, and this is what we call their schema, generally a title, the structure, and the types of the different attributes of that event. And it's a general principle that teams should share their schema rather than sharing data, i.e. sharing a database or sharing a huge amount of code. We can build very tightly coupled systems if we share data or share code and have that distributed serverless monolith and that Lambda Pinball that we talked about earlier. Instead, we have a very strict schema between the services. All teams are aligned on the schemas and know how to listen to events of that schema. It's a lot easier for teams to work independently while collaborating to produce the overall system. One interesting thing to mention is the EventBridge Schema Registry. So this is no longer in preview. This is now generally available across all AWS regions, I believe. And this, you see, we got our events coming in and they can go through different event buses. We talked about having one custom event bus in our case, and rules can then route them to different places. But Schema Discovery can automatically look at the events going through your system and build an automatic representation of those in the EventBridge Schema Registry. Something that looks a bit like this with the events, the type, and the properties. Now, this is very useful when you have teams working independently, but generally I would advise against automatic discovery and instead getting your team to design those schemas together so that all teams are aligned on what they're expecting. And you can then encode those schemas by uploading them into the schema registry and turning off the automatic discovery. The result of all of this, and I realize we've gone through this quite quickly, is that we get our logical grouping of services based on the underlying business processes. We know that the entities that they're working with are the same terminology as the end business. And we know that if, let's say, one department here uses a term to mean a certain thing, and another department here uses it in a different context to mean a different thing, even if we can't challenge the business to change their terminology, we know that the code is going to be separated. And if these two do need to communicate, they're going to do it over a structured event that has an agreed schema between the company, between the different services. So Amazon EventBridge is forming that almost enterprise service bus, but with much more abstraction and no management of running that. Different services can publish as events to that event bus, and they can get picked up by other services through routing rules. This gives you a great amount of ease in coordinating how different teams work together. And this team potentially doesn't have to actually call or Slack or email this team to find out how they're representing a certain event, because they can look directly in the EventBridge Schema Registry and work independently of having to coordinate with them. And that EventBridge Schema Registry can also include types, so you can really start to get some validation across the interaction between these different services. So that's EventBridge Storming, a specific variant of event storming that reduces rework and tight coupling for teams building state-of-the-art serverless event-driven architectures with EventBridge. And a quick sidebar on this. Actually, before that, if you do want to read a full guide on this, you can go to the Serverless Transformation blog, which I've written, and that goes through and breaks down those 8 steps in a bit more detail. But the quick sidebar that I was talking about is how do we trigger an event? So Amazon EventBridge allows you to trigger an event through the API. So the different services will use the Amazon EventBridge API to send events and know that they could be picked up by different services. And if you want to put an HTTP sort of API on top of triggering those events, you can use API Gateway to automatically trigger an EventBridge event, or you could just have a Lambda function behind API Gateway being sort of the reverse proxy here, to then trigger that event into Amazon EventBridge. But as a developer, it can be a bit painful to have to set up a particular Lambda function to know that you can trigger a particular event when you're developing. And using the SDK, although it's easy to use, it's not as natural as hitting a Postman API. And this is where an open source project that we've worked on internally can be quite useful when building architectures based off EventBridge. So the project is SLS DevTools, which is an in-terminal tool for building serverless event-driven architectures. And we use it a lot on our Python projects. So it runs completely in the terminal. You can install it, actually it's installed via npm. The tool is written in JavaScript, but works perfectly with Python architectures, Python microservices. After you install it, you then run SLS DevTools and give it the name of the CloudFormation stack, which is the AWS representation of the architecture. And you can then see the different Lambda functions, invocation history, logs, duration, location of your architecture, and some other metrics. We're going to have a quick look at those, but then we're going to look at how does this link into EventBridge and how does that link into the event-driven architecture that we've just built. If you do want to check it out, it's on GitHub, but I'm just going to quickly demo the functionality first. So after running it in the command line, the user can then select the Lambda function, the compute part of the serverless architecture, see the invocation history of that, get the server logs, and also understand the duration of that Lambda function. Now, if we tab down to this event bridges section, we can go onto our event bus by hitting enter. We can insert an event directly into this, giving the type of that event, the body of that event, and then when we hit submit, that will push that event into the event bus, and we'll see that this Lambda function is listening to that event. We'll see the result of that and get the logs. So this makes the feedback for developers working with EventBridge-based architectures a lot tighter. They don't have to go to the AWS console. They don't have to write a quick script to trigger things into the event bus. Instead, inside their terminal, they're able to trigger events and also repeat those events as they go through. Also, that schema registry that I talked about earlier is completely built in. So you can browse the different events that you have going through your event bus. Then if you select to use one of those events, a form is dynamically populated based off the structure of the event, allowing you to then enter an event of that structure into the system and see if your compute reacts as you expect. If you're interested in the SLS DevTools project, do check it out. It really helps when you're building these event-driven serverless architectures, and it's completely open source. If you have any feedback, feel free to open it. Jumping back to the EventBridge Storming part of this talk, though, I just want to summarize what we've gone through. So I'm just going to jump back. I should put an extra slide in. We've gone from step 1, where we've got the complex business domain. We've then discovered the events from that, working with the business. We've then put those events in order with the business again, figuring out any missing events and making sure our understanding of the processes is good. Trigger detection could be useful to sort of match us to the user stories, but we didn't have a look at that today. We then categorized into the entities, so looked for the different nouns that we use to make sure that our understanding of the terminology aligns with the business, and also see the logical inconsistencies to make sure that those inconsistencies don't occur within the same service, but are split into different services so that the code complexity is lowered. After building those sort of bounded contexts, the groupings, we then looked at what microservices are needed. It seemed that if one entity is used in different microservices, we need to be aware that we need to duplicate data, or we need to think about the structure of our bounded context to see if we need to change. Because if you do have 2 microservices that are calling each other a lot, it can actually be a good case to merge those into one, rather than deal with the complexity of orchestrating that. We then created a single event bus using Amazon EventBridge, allowing us to publish events and get those picked up by different microservices. And then we use the EventBridge schema registry to store a structure of the events. And although we can do that automatically, I advise that you work as a team sort of in another workshop to figure out what the structure of these events is. I often commit those to version control. You upload them still to the Amazon EventBridge Schema Registry, but having them in version control allows people to review the changes that are going to be made, and that's your living documentation of the event structures. And by having this living documentation, both in the Schema Registry, which can be picked up by dev tools like SLS dev tools, but also having that in version control, it means that teams can pick up events from other services without having to contact them, without having to get them to write a new API endpoint. And we avoid the sort of distributed monolith of having these synchronous requests between services. And instead, we rely on asynchronicity to pick up the events going through. I realize I've gone through that quite quickly. I think we're going to have quite a bit of time for questions here. And if you want to check out any of this content, you can follow me on Twitter. The slides are public at slides.com/Ben Ellerby. One of those QR codes will take you to the newsletter. The other one will take you to the blog. I'm not sure which is which, so please subscribe to both. And yeah, if you've got any questions, feel free to ask. Sorry for going a bit quick there.